Hello everyone, let's dive into a ZIMSEC November 2004 differential equation question. This is a classic exam style problem you must be ready for. Alright, 8 item A reads, find the general solution of the differential equation cosine of x dy dx plus 2 sine x equal to 3 tan x. B, a car travels a distance of 50 kilometers with an initial speed of 80 kilometers per hour. Given that the car's speed is proportional to the distance that remains to be covered, find the time to the nearest minute that the car takes to cover 3/5 of the distance. So guys, let's go ahead and get started. Okay, so we are starting with the first problem, which is a variable separable ordinary differential equation. That's a first order. All right, so 8A. All right, so number 8A, it reads, find the general solution of the differential equation cos x dy dx plus 2 sine x equal to 3 tan x. Right, so firstly guys, we need to separate the variables. So I'm going to subtract 2 sine x from both sides so that we remain with cosine of x dy dx equal to 3 tan of x subtracting 2 sine of x. Right? Now let's divide everything by cosine of x. So dy dx equal to 3 tan of x over cosine of x minus 2 sine of x over cosine of x. Right, so now I have to manipulate this, or maybe I have to rewrite this in a clean way so that we are able to identify the exact integration techniques to use. All right, so integral of dy is equal to, so I can take out the 3 here, then I'll just say integral of tan x, right? 1 over cos is sec x, right? Then I'll do the same here, but I'm going to put a plus there, then I'll put the 2, then I'm going to put a negative inside. I will explain why I did that. Then dx, right? So now allow me to make some few annotations here. Okay, so suppose, right, this is just side work for you to understand this. All right, suppose I have 1 over sec, which is 1 over cos x. Remember, this is sec x, right? So if I'm to differentiate here, u is equal to 1, then u prime is 0, v equal to cos x, v prime equal to negative sine x. So if I use the quotient rule, it's v du, so it's going to be cos x du is 0 minus u that's 1, dv is negative sine x over v squared, cos squared x, right? Which simplifies to just sine x, right, over cos x times 1 over cos x, which is equal to tan x, which is equal to tan x sec x. So, right, if we differentiate sec, we get tan x sec x. So this implies that when we integrate tan x sec x, we must get that sec x, right? Okay, so we are done with the first part. Let's go back. Let's go back to this part, right? So we want to use a recognition that first derivative over the function here, dx, if we differentiate, we must get natural log of function of x. So we know that when we differentiate cos, we get negative sine. So it means if we integrate this, so if we integrate negative sine x over cos x, right, we must get natural log of cosine of x, because when we differentiate this, it's just first derivative over the function, and we know that our first derivative is negative what? Negative sine x over cosine of x, which is that one. So now that we know the integration techniques to use, let's go back and solve that. All right, so allow me to rewrite that and just say, okay, all right, so we have integral of dy is just 1 equal to, I think I had a 3 here, so equal to 3 integral of 3, sorry, I put a 3 outside, integral of 3, then it was tan x sec x dx, right, my plus 2 integral of negative sine x over cos x dx. So here it is just y equal to 3 sec x plus 2, then natural log of cos x, right, then plus c. Remember, the question requires us to write the general form of that, to find the general form of that. Right, so basically that's how we solve this problem out. Okay, so now let's move on to item B. We are now moving on to item B, right? So on item B, it's saying a car travels a distance of 50 kilometers with an initial speed of 80 kilometers per hour. Given that the car speed is proportional to the distance that remains to be covered, find the time to the nearest minute that the car takes to cover 3/5 of the distance. Right. So right now the question seems to be like complicated. It looks complicated at all, but once we break it down, it's going to be easy. So let's start with the first line. A car travels a distance of 50 kilometers. Right. Meaning say the total distance traveled here is 50. Right. So I'm going to write it down. So total distance, this was 8b. Right, so total distance traveled, right, total distance traveled is 50 kilometers, right. Then we are also told that the initial speed of, it has an initial speed of 80 kilometers. So it means when t is 0, that this means initial, right, then the speed, right, is equal to 80 kilometers per hour. Right. So now, guys, there's one thing that we don't know, because the next line or the next statement says, given that the car speed is proportional to the distance that remains. So do we know the distance that has been traveled? No. So we can so we can just say, let x be the distance traveled. Okay, let the distance traveled after t, let the distance traveled. So in this case, let me just say let the distance traveled after t hours, right? Since this, okay, so let the distance traveled after t hours. In this case, okay, let me use hours. T was t, okay. After t hours, b, bx, right? Okay, so when that distance is x, so it means the remaining distance is equal to the total distance minus the traveled distance, which is 50 minus x, right? So now the question says, given that the car speed, right, since we have let that distance be x, so speed now, we are going to say dx dt, that's the speed, is proportional to the remaining distance, right, to 50 minus x. And we know that every time we replace the proportionality sign, we put dx dt, we put equal sign in the constant, so 50 minus x, right? So we can find the value of k using the initial conditions. Remember our initial conditions when, in this case, when the distance is 0, when time is 0, right, you're going to see that the distance traveled is 0, and at the same time, this dx dt is equal to, dx dt is equal to, it was what? Okay, so we need that one as well. Okay, so guys, to find dx dt, in this case, it was, oh, it's 80, it's given. So it's 80, I'm sorry. All right, because it's saying a car travels a distance of 50 kilometers with an initial speed of 80. Right, so let's use that information to find k. So dx dt, that's 80. So here we say 80 equal to k, then 50 minus 0, because it means initially we haven't traveled and we are still at the same spot, right? So now if we divide, so k is equal to 80 over 50, which is 8 over 5, right? So we now have 8 over 5. So let's go ahead and write dx dt is equal to 8 over 5, 50 minus x. But remember, we need to find the time to the nearest minute that the car takes to cover 3/5 of the distance, right? So here we would need to solve and find time when the distance here is equal to, so when x is equal to 3/5 of the what? Of the, since the total distance was 50, right? So when x will be 30. So we want to find if we travel 30 kilometers, what will be the time? Okay, so let's go ahead and solve this. So I'm going to separate the variables. So dx over 50 minus x, right, equal to 8 over 5 dt. I'm going to integrate. So if I differentiate here, I'll put a negative and a negative outside. So the answer is going to be negative natural log of 50 minus x equal to, right, 8 over 5. Is it 8 over 5? Yes, 8 over 5t plus c. Right, so to find c, remember our initial conditions. When t is equal to 0, x was what? X was 0 there. Right, so negative natural log of 50, right, minus 0 is equal to c. So when c is that, right, we are going to have this, our particular solution, negative 50 minus x equal to 8 over 5t minus natural log of 50. So now we use that to find t. So remember, we are looking for t when x equal to 30. So now we are going to say, if we bring this over, so we have natural log of 50 minus natural log of 50 minus 30 equal to 8 over 5t. So this implies that t is equal to 5 over 8 of natural log of 50, all right? Okay, of natural log of, this is 50 over 50 minus 30, that's 20. So 50 over 20 or 5 over 2. So whatever we get is the answer here. So it's going to be 5 over 8 natural log. So it's 5 over 8 natural log of 5 over 2, right? So I'm getting 0.5. Okay, so here I'm getting 0.572681704, but these are hours, and they ask, they require us to find, to express the answer to the nearest minute. So to convert hours into minutes, we just have to multiply that. If you multiply this by 60, we'll get the minutes, right? So here, when I say 0.5762 81704 times 60. What do I get? So if I multiply that by 60, I'm getting 34.36090245, which is equal to 34 minutes to the nearest minute, right? That's 34. All right, guys, that's it for today. Thanks for watching. Stay sharp and keep pushing with me at the Trockers. See you later.